Hi folks, this is Sarbjeet Johal coming to you from IBM TechXchange in Las Vegas. This is day 2, and today we're going to talk about the very peculiar problem of customizing the frontier models for your business. So infusing your data into the models or putting that side by side to the model so you can build applications based upon your data, which is meaningful to you. That's your differentiation in your domain, in your company, as a country, and or as a state, and your culture, whatever that happens to be. So in that context, I have a great guest who has built something, I think, very creative, clever. His team has built it. He is the chief architect of InstructLab at IBM. With that said, let's welcome Akash Srivastava. I would say Dr. Akash Srivastava, PhD in generative AI, generative models, right? Welcome. Thanks for your time.
Thanks, Sarbjeet. I'm very, very glad to be here.
Thank you. Let's get started with the differentiation between RAG, fine-tuning, and prompt engineering. And then how you guys came up with this newer approach, which my understanding is it's more of a RAG simplified.
Yeah, let's get into all of these topics. I mean, I think these topics are all the rage these days. So let's start with fine-tuning. And at a very high level, fine-tuning is about saying, I have a great pre-trained model, and I want to make it do things that I care about. Maybe I want to write, I write summaries very often, so I'm going to train the model how to write summaries. Maybe I do a certain kind of style sheet generation or certain sort of processing on my data, and I want to teach the model these basic skills, right? Mm-hmm. So what we will do in fine-tuning is we take the data, convert it into a certain format that a language model can accept, and then we train the model. Now, the hope is, if all things go well, the model will be able to do these, acquire these new skills, acquire these new knowledge, and perform the tasks that you intended to train it with. Okay, so now then you have these proprietary models, frontier models like GPT-4, and you'll say, Akash, but we can't fine-tune it. So how do if I want to ask a question on my data, what are the options? And that's where RAG comes into the picture. The way to think about RAG, and I always give this analogy, is it's like an open book exam. You think about GPT-4 as like a kid, never studied an exam, and before the exam, so now the day before, the teacher says, you know what, kid, we're gonna make this an open book exam where I will give you the book, I'll ask a question, there's a retriever involved that goes and says, let me find the relevant parts of the book that pertains to this question. I'll give all that back to GPT-4 or the frontier model of your choice. And then its job is to sort of extract the answer from that certain section and say it in a way that you asked it for, okay? That's what RAG is, right? And then you asked me about prompt engineering. So, language models, especially when you are talking about not the biggest models out there, they are sensitive to how you ask them a question, right? So you may ask the question one way, write an email to the CEO in a particular way, and then, it may give you an answer that you like, but it's not all the way there. Now, think of prompt as the levers that you have in order to direct the language model to fine-tune its output to your specification.
Yeah, it's a context injection.
Exactly, right? And that's sort of how we lay these three things out.
So, describe the sort of basic architecture without giving any IP information. How did you guys come about it, and what was the main problem you were trying to solve? And it's important for our viewers to know that you're part of IBM research, and you guys came up with this project rather quickly and put it out there rather quickly by IBM standards.
Oh, great question, because I think I wanted to, because you said, without giving any IP information out, the best part of this entire effort, InstructLab, is that it's open source, completely open source. And so I can actually talk about every single component in it in full details.
Nice.
And then B, the speed. You're right. I mean, we partnered up with Red Hat, amazing folks. We went from the idea to the GA in 9 months. As you said, I don't think anything in IBM's history has been released that quickly. So let me give you a sort of a high-level overview of what this tool is, how we came about it. So the problem that we always encounter, you must have all heard about this, small models are going to be the workhorse of enterprise LLM, right? But what does it really mean? Like, why? Okay. The basic idea is, and as we touched upon, you have these frontier models, these models that you can access through APIs. They're expensive. They're large. When you compute the cost of inference, especially at the scale of enterprise, guess what? Very, very few people can actually afford these models. Now, the question is, can we take a small model and then customize it in a very, very targeted way? And I'll tell you what customization means in a bit. But in a very, very targeted way to do the tasks that the enterprise cares about. That is what led to InstructLab. It's a toolkit that allows you to customize the model. It's a tool that says, Akash, I don't care about these 15 things. I don't care about getting a joke out or a particular, emoji that my model generates in every email. I care about my customer service agent. I care about the use cases where I need to draw summaries from some
domain specific, like if you're
Exactly.
if you're customer service of Ford, like you want to know the car parts and all the engine types and all the stuff like which pertains to that domain. That
great example,
business, right?
Very great example, because, and this is where we will connect from the previous discussion. If you have to do it today with a proprietary model, your only option is RAG.
Yeah.
But RAG, as we discussed in the analogy, it's like an open book exam. The data is not really in the model yet.
Yeah.
So in some sense, it's limited in what it can do with that data.
And latency is also a problem?
Latency is a problem as well, as you rightly said. So when I say customization, really think about taking that data, your biggest, most valuable asset in an enterprise, and baking it systematically into your own model. When the model knows these things, and we're discussing this is through a fine-tuning process, well, it's going to perform better than any model that is trying to do this through a certain hack. I'm not saying RAG is specific a hack, but it is not the same thing as putting the data in the model.
Yeah. So, okay. With the mechanism what you guys have with the InstructLab, the data gets infused into the model or it sits on the side, and do you do any vectorization of the data? Before we go there, actually, I did the lab yesterday here, InstructLab lab here. The most important part of that was creation of synthetic data, the step, what happens. It takes a few minutes, a couple of minutes, and by the way, it's pretty lightweight. You can do that on a M3 MacBook Pro for test cases. For production, you have to go to the cloud and heavy-duty machines. Having said that, I think that was the most interesting part. So it takes that small amount of data, and then it creates a lot of synthetic data. So all the permutation and combinations of language gets baked into that. And then my question is, does that data go back into the model? Number one. Number two, do you do anything with the vector databases or anything like that during that process? What happens behind the scenes a little bit?
Great question, Sarbjeet. And then again, once again, very great setup, because we were talking about what customization is, and I'm going to use your example to explain that process and then answer your question in the process. So when we say customization of a model, it basically comes down to two things. Synthetic data, as Sarbjeet mentioned, and the process through which you take that data and put it into the model. In this case, it's be fine-tuning, as we described in the first part. So if you look at the offerings from bigger players in the market on, that claim to provide you with a tool of, you can customize the model, pretty much all of them are providing you that second thing. They assume you have the data, and then you want to put that data into the model. So, you could do it through PEFT or LoRa or, or a full fine-tuning.
Yeah.
But as you mentioned, the pain point is, how do I get the data?
Yeah, exactly.
Right? I have tons of PDFs lying in my enterprise or other form of data in Excel sheets and documents, but I can't put that data directly into the model. The data has to be in a certain format, like question answer, as you said. So what we actually do, and you described the process beautifully, is that we ask you to give us 5 examples of what kind of question and answer you're gonna actually be using this model after it is trained.
Yeah.
We take those 5 examples and we make millions out of it by using your documents, your data. So it's all grounded in your data.
Yeah.
Now, what we have done is that book, you remember that we were saying the book analogy in RAG?
Yeah.
That book has been converted to a format where now the language model is ready to take it. So we use the second part, the fine-tuning, to now take that book and bake it with the model. I hope that answers your question. Yes, the data makes its way into the model through the tool of fine-tuning.
Yeah.
And you can now just ask things, that you sort of wanted this application developed for, and the model knows.
Awesome. So it hides a lot of complexity and a lot of learning which developers have to do to use all these different mechanisms to prep the data and then put that in the right format. You just pass it the information which is very meaningful to you in sort of natural language, or it can be relational database tables as well. You can push some of that into that as well.
Some of the tabular data can be, actually some of the POCs we have done, we've actually looked at tabular data. And like you said, it's your enterprise data.
How you want to push it.
How you want to push it, that process of converting it into a training data.
Yeah.
For which typically you would go to some data provider which will have to do it manually and will charge you millions of dollars. And that's why I was saying that the pain point of customization is really in the data, which is what InstructLab automates by its synthetic data generation processes.
So it's an economical way to get your data into a model. It can be small language model, it can be mid-sized language model. So you guys are using Granite, which is much smaller than some frontier models from other providers, and shed some light on that, like how the combination of that relatively smaller model, Granite, which is a frontier model for you guys, and the combination of that and enterprise data, it makes it much more powerful than bigger or the baddest, according to people, frontier models. So it makes you even more effective than that.
Yeah, no, absolutely. So let me set some context here, right? Why would you want to use a small model? If you can, for example, have access to the best or baddest model out there. Well, it's the cost of inference. Large models, so far what we are finding, and probably the audience knows very well, are very expensive to run and deploy in an enterprise. So naturally, you would want to reduce that cost. The way we approach this is, customers, especially when you're deploying a language model in an enterprise setup, it's doing certain very specific things. It's not out there to be used in the same format that we use for proprietary models these days. So if you use these models for something very specific, what you really want to do is take a small model and customize it to do that one task. Once you have done that, you have drastically reduced the price. You have, by some estimates, and we'll share some more information on this, you can reduce the price by 50x while not having any drop. In fact, we'll show you some example. The performance actually goes up because you're really honing in this model. I mean, we call it a small model, but an 8 billion parameter Granite model, it's not small.
Not small, it's still big,
Yeah.
So the economics improves, and then you get to use your domain specific, experts, number one, the skills from your workforce. They can easily sort of move on to using this mechanism, and it's cheaper, faster, better, and more human-friendly, I guess.
It is. It is. We're really making this tool in a way that a subject matter expert that does not know much about data science or machine learning or language model can still come in and say, hey, Akash, here are my 5 questions of what a skill or a piece of knowledge that I want to teach this model. And that is all they need to know. I hope we'll keep making this tool more and more user-friendly. I also quickly want to touch upon, you mentioned RAG in the beginning, and I want to connect the dots between, we said InstructLab uses fine-tuning and synthetic data generation methods to put the data into the model. So where does RAG come into the picture? Well, while you can take your data at any given point in time and put it into the model, you may still want to use a RAG system because, say, your data changes very often, or as you sort of your training is scheduled for the model is at a different cadence than your data changes that appear in your data.
Yeah.
So what we did is in a study of this, right? So what happens if you take a model that already knows your domain and then you're doing RAG? And guess what? You give me any model, this small, very small 7B, 8B models, they will outcompete any generic frontier model on that RAG task.
Because it already knows a lot.
Because it already knows, right?
Yeah.
Because RAG, as we discussed, is generally not so bottlenecked by the language model. It is bottlenecked by the quality of the retrieval. What if the retrieval gave you the wrong chunks?
Yeah.
A model that knows the content, as you just said, can correct it. And it's like, well, I know this context is irrelevant.
Yes.
Because I know from memory.
True. No, that's a great point. Actually, getting into the use cases, then where you think this is not the right approach, but do RAG or fine-tuning or other mechanisms?
Great question. I think the way to think about this is, are you really seeking, or your use case, is that of a customization or not, right? So what do I mean by that? If you are saying that there are a handful of things, or 2, 3, 4 things that I want my model to do really well, I'm looking at reducing the cost while either maintaining the performance or improving it, you should use InstructLab. But if you're trying to make a generalist model, a model that just does well across everything, I think InstructLab alone is not the answer.
Yeah.
Making a frontier model that is what I call actually a generalist model requires a number of techniques. InstructLab will be a part of it, sure, but not the entire pipeline.
Got it. So actually, you touched upon this earlier in one of the sort of parts of the discussion, which I also mentioned a lot of time, that the frequency of change in data, it's a very important aspect of this whole sort of fine-tuning versus RAG versus prompt engineering and this mechanism, what you guys have come up with. So if the data is changing every second or every minute, right? What's a better mechanism versus if the data is changing on a weekly basis or monthly basis or like semi-annually or annually? So like as you go, like as the frequency of change goes down, I think the case for making the data into the model becomes stronger and stronger, right? Is that how you see it?
I mean, that's a great point. That's a great observation. Yes. So let's break that down, right? So you're right. I mean, if your data is changing hourly, I don't think it makes sense to keep your model on the training burner, right? And primarily because you're not going to see any improvement in the efficiency from an economics of LLM perspective. However, anytime you can specialize your model or give it the domain knowledge through fine-tuning or InstructLab-based fine-tuning, it helps it understand the context. So yes, let's say you have in a certain domain, let's assume something where 5 transactions happen every hour.
Yeah.
It doesn't make sense to keep training this model. However, you would appreciate the fact that if your model knows your context, okay, historical transactions, also what are the specific columns, what do they mean? Right?
Yeah.
You can go and ask so many meaningful questions, right? And that's why I really like this question, because it basically, in a real world scenario, you would still want to put your model in a RAG setup, right? Even if it's fine-tuned.
Yeah.
The benefit you're getting with fine-tuning is the on the cost side. You're saying instead of deploying a proprietary model by InstructLab, fine-tuning the model, I can get the model's base capacity on this domain better than any proprietary generalist model, and then put it into a RAG setup.
Got it. So yeah, so I think the idea is that there's a frontier model, which is good at all generic things. Then you tack on your data with InstructLab mechanism for quick training, which is very economical.
Yes.
And it works with smaller models even better, right? And still, I think still the question that question remains in my mind, that how will we pull the data as programmers of business application developers, actually? How will the business application developers pull the actual transactional data, what are systems of record, where the data accuracy is of utmost important? Like, this is what my understanding is, that these models, which can be frequently retrained or augmented with the newer information, even at weekly basis or even a daily basis with newer mechanisms like InstructLab. It's good for anything which pertains to the language or the graph of the business or the knowledge base of how your system operates and what is related to what, and all the intricacies between different objects and processes. So it's good in that context, but when it comes to numbers, that's where, in my mind, that these things kind of fall apart. And how will we glue these two things together is... do you have any insights into that?
I mean, let's address this issue, right? So, language models, in general, don't like numbers.
Yeah, true.
Now, the smaller they become, the problem becomes a little bit more exaggerated. Immense progress has been made in fixing these issues, and
injecting the math models into
exactly, like a lot of granite performance on some math benchmarks is amazing for a small model. But you're right. Forcing a autoregressive language model to do math is a bit of a... May I ask this question, is that the best approach? Maybe not, but that's where tool calling comes into the picture.
Yeah.
So you must have heard about this a lot here in the conference. And the reason is that, I mean, for math and things that have that sort of algorithmic flavor to them, what we are doing now is we are giving the language model the ability to call a friend, a calculator, and say, hey, I have this number and that I extracted from the table, but now this user is asking me to manipulate it. Could you do that manipulation?
That's where I think agents will come into the picture.
Absolutely, that's absolutely why we are so bullish on the agent trajectory, especially in the enterprise, where, as you rightly said, I mean, pretty much all pipelines have some manipulation involved, where you have to call a bunch of friends. So your business, if you look at any knowledge graph of business processes, they are interconnected with a bunch of tools. I mean, a language model, really, nobody thinks, I hope, that the language model will replace all of those tools. The purpose is to make the language model work with all the existing tools.
I think that's a great note to end on. So with that, I mean, that gives us a good news to the practitioners, the programmers, like, hey, we are still needed. Programmers are still needed. Architects are still needed. And there's a big difference between programming and coding, as I usually say that. The Gen AI can do, most of the coding, but programming That means defining the interfaces, interdependencies, which friend you want to call when for that help. The math model, give me my current sales model, whatever that happens to be. Not the model, in this case, agents. Which agent will be called when, and how those will be glued together still will be needed. That information will be fed still by humans, and oversight will be done by humans for foreseeable future, I think. So with that said, thank you, Akash, for your time, and it's a privilege to talk to you, and I look forward to having a longer discussion on like a very deeper level sort of concepts of zeros and ones.
Absolutely, it was an absolute pleasure.
Thank you, appreciate it. All right, thank you very much.
That's awesome.
Yeah.
I really enjoyed it. No, bang on.